Hey people, it seems like some of us are having a little trouble with Half-Life problems. That's reasonable. Half-Life problems can be really tough. So we're going to go through one of them together, and hopefully this will help you solve some of these problems in that IXL you're working on. So the one I'm going to do, and I'll attach this as a little screenshot, it says the half-life of a radioactive kind of strontium is 10 hours. If you start with 80 grams of it, how much will be left after 20 hours? So a half-life problem, we're still going to kind of use this. It's more of like an application of using exponentials and their relationships. But we're going to use a very similar form to this. So y is still going to represent how much we want to find. A is still going to be our initial amount. So here we start with 80 grams. So we're going to put an 80 in. And now we have 1 minus the rate. For this, they don't give you a percentage, and for this, you kind of need to know what a half-life is. So the half-life is going to be when half of how much you have is gone, so you're left with half remaining. So the half-life means like you're reducing by half. So it would be like 1 minus 1/2. So when you have half of whatever it is left. And the time here, this is where it gets a little confusing. They give you units of measurements with time for this. They give you the half-life is 10 hours, how much will be left after 20 hours. But when you think to the purpose of the exponent, having a variable, it's really telling us how many times we're going to multiply whatever the base is. Like when we're doubling something, it's 2 to the x or 2 to whatever power. It's how many times are you multiplying by 2. So for a half-life problem, it's how many times are you taking the half-life? How many times are you cutting what you have in half? So we were given the half-life is 10 hours. So the half-life is 10 hours. And we want to know how much is going to be left after 20 hours. So we're going to end up taking the half-life. Well, it takes 10 hours to get the half-life. We're curious on how much it's going to be left after 20, so we're going to take the half-life twice. So this is like how many times you're taking half of what you have. And if we simplify this, we're taking 80 times 1/2 to the second power. So you're starting with 80, you're taking half of it every time, and you're going to do that twice. So for this problem, this would be the equation we set up, and that would just be 80, the half, or 1/2 squared is times 1/4, so 1/4 of 80 equals 20. So after 20 hours, there would be 20 grams left. Now I'll also help you with maybe some other ones, just because that little exponent can be a little tough. Let's say the half-life is still 10, but let's say we wanted to know, this will be like a little hypothetical here. Let's say we wanted to know how much was left after 40 hours. Well, it takes 10 hours to achieve a half-life. So that means we would have a 4 in the exponent if we wanted to know how much left was after 40 hours. So you would put, or you would just take half of this again, then half another time, because you're going to multiply by a half 4 times then. You even could have, let's say, maybe we're interested, because things don't always work out as nice integers, how much is left after 35 hours. Well, you still would do 35 divided by 10, and you're going to end up with 3.5. You would just put a 3.5 up in the exponent. You're not quite taking 4 half-lives, you're getting like 3.5 of them, because the half-life doesn't just instantly happen, it kind of happens as you go, it progresses, and after a full half-life, you've lost half of what you have. And that'll have like the exponential growth relationship to it. So as you get lower and lower when taking a half-life or cutting what you have in half, you kind of keep on taking less and less and less, because half becomes a less value. Like the first time you take half of 80, you're taking 40 away. Then when you take half of 40, you're only taking 20 away. Then when you take half of 20, you're only taking 10 away. It keeps on getting smaller and smaller. That's like this part of the graph right here. Alright, I hope this helps us, and I hope we have a good rest of the day.